Yes, hi everyone. Good morning today. Today the real numbers is continued, and in that the part is the fundamental theorem of arithmetic. Already we know that division lemma, which is A is equal to BQ plus R, and R is lies between B and greater than 0, division lemma. And also this division lemma is used to find the HCF. But how to find the LCM? At that time, the fundamental theorem of arithmetic, what it defines. So before going to define fundamental theorem of arithmetic, what are prime numbers? What are prime numbers? And composite numbers. And what are their product? Then of this we can define the fundamental theorem of arithmetic. So what are prime numbers? Yes, some examples I am writing here. 2, 3, 5, 7, 11, 13, 17 are prime numbers. Are primes. Yes. And here 2 into 3 is 6. 2 into 3 into 6 is 13. 3 into 5 is 15. 3 into 11 into 7. Like that. 5 into 7, 35. 35 into 2, 70. Just for example. Yes. 7 11s are 77. 77 2s are 77 2s are 154. Is it? Yes, understand? 2, 3, 5, 7, 11, 13, 17 are primes, I am saying. Why these are called prime numbers or primes? And what we can tell about these? Is it? So, when you are observing 2, 3, 5, 7, 11, 13, 17, 13 means 1 into 13. 17 means 1 into 17. 7 means 1 into 7. What are these? 1 and 7 are called factors of 7. 1 and 13 are called factors of 13. 1 and 17 are called factors of 17. So like that, so many big numbers you can give. So observation is the numbers which are having only two factors, 1 and itself. The numbers which are having only two factors, 1 and itself. It means 1 and itself. Only two numbers are dividing completely the given number. Then the numbers are said to be prime numbers. Understand? Yes. So here 6. Here 6. 6 is the factors of 6 are 1, 2, 3 and 6. You know. And factors of 30 are 1, 2, 3, 5, 6 and 15 and 30. So these are all numbers are dividing the given numbers. It means here in this number the factors are more than 2. More than 2. Only 2 are the factors, then they are said to be prime numbers. If the numbers having more than 2 factors, means more than 2 numbers which are dividing the given number are said to be composite numbers. Are said to be composite numbers. So what we can write here? 30. 30 equal to, we can write 2 into 3 into 5. Yes. And 154 equal to 2 sevens are 2 sevens. It means 154 equal to 2 into 77. And 55 is equal to 5 into 11 and 105 equal to 3 into 5 into 7. Easily, very easily you can understand that. It means you can write every composite number is product of its primes. See now, 2, 3, 5 are prime numbers, 2 and 7 are prime numbers. Here also 2 into 11 into 7. 2 into 7 into 2, 7, 11 are prime numbers. 5 and 11 are prime numbers. 3, 5, 7 are prime numbers. It means you can mention here 105 is a composite number, 55 is a composite number, 154 is a composite number, 30 is a composite number. So every composite number is always expressed in the form of product of its primes. Product of its primes. Products of the prime numbers. This is said to be fundamental theorem of arithmetic. Once again, I will find that every composite number, whichever number can give that is composite number. Every composite number can be expressed in the form of the product of its primes, and they are always unique. 2, 7, 11. They are unique, and they can be also 7 into 11 into 2 is also okay, or 11 into 2 into 7 is also okay. Order is not important. Without order, it means you can write in any order. Order is not important. So, but they are all primes. So once again, the fundamental theorem of arithmetic defines every composite number can be expressed in the form of product of its primes, and always the numbers are always unique and order is not unique. Okay, so this is fundamental theorem of arithmetic. So therefore, fundamental theorem of arithmetic, you can find the HCF and LCM. So now 30 and 154. An example from this we are going to continue. So what is the LCM? What is the LCM? Already in lower class you have studied so much, very well. Yes, HCF means highest common factor. First work is to write in factors, then among that common, if there is a common, among that the highest one, that is a factorization, but you know that. Is it? Okay, so now, and one thing here, yes, 30 is equal to 2 into 3 into 5. Yes, 154 means, yes, you can write here 154. 2 sevens are 7 11s are 11 150 means 2 into 7 into 11. Yes, so what you can tell? Common factors. 2 is only the common factor. So HCF is equal to 2. Yes, and LCM equal to, LCM means common factor into all the terms which are not common, least common multiple required. HCF means the number which divides the given numbers completely among the highest. LCM means least common multiple, the number what I get in the LCM which is divisible by the given numbers among the least common. Is it? So that is equal to 2 into 3 into 5 into 7 into 11. This is LCM equal to 2 3 the 6, 6 5 the 30, 30 into 11, 33, 7 equal to 0. Yes, this is LCM. Yes, by this what you can understand here, LCM means which divides the given number completely, maximum, highest. Least common multiple. This is least common multiple which is divisible by 30 and 150. So this is HCF and LCM. This is said to be expressing the product of prime numbers for composite numbers. So HCF can find easily, LCM can find easily. So there is HCF into LCM. What is that? 2 into 2 3 1 0 multiplication. Product of HCF and LCM of the two numbers or more than two numbers, no problem. Equal to this is product of HCF and LCM. And what is the product of the terms? Terms you can just written that A and B. Right? So A into B, A and B are the terms. That is 30 into 154 equal to S10 3 4 are 12 L1 3 5 are 15 3 5 are 15 plus 1 16 L1 3 1 are 3 plus 14. It means you can understand that there is a relation between the terms and their HCF and LCM. So you can understand that H into L is always equal to E into B. This is the relation between the two terms and their HCF and LCM. Very important relation. S H of A and B means HCF of two terms A and B. L of A B means LCM of two terms A and B. Therefore H into L is equal to A into B. The product of the terms is always equal to HCF and LCM product. Yes, from this you can understand that H is equal to A into B divided by L. Secondly, LCM equal to A into B divided by HCF. What terms if you require? A equal to H into L divided by another term, and also we can write that B is equal to H into L divided by H. These are very important relations. Okay. That is H into L is equal to B into L. By this you can write in different way. Yes. This is composite number expressed in the form of product of its prime. That is said to be fundamental theorem of arithmetic. Yes. Now, just by going dividing the taking the prime numbers. Yes. So divisibility test, we know that the number is said to be divisible by 2. Its unit digit is must be 0 or even number. Just for example, 2, 5, 7, 6, 1, 3, 2, 8. How we can understand this is divisible by 2 or 3 or 4, 5 like that? So first condition is divisibility of 2. If last unit digit is even number or 0, means 3, 5, 7, 8, 9, 0, means unit digit is 0. If unit digit is 0 or even number, then that number is divisible by 2. That is divisibility property of 2. Is it? And just small example, sum of the digits 3 plus 1, 4 plus 5 is equal to 9. Sum of the numbers. 9 is divisible by 3, so the whole number is divisible by 3. That is divisibility property of 3. And just for example, this also, and also it is divisible by 5. Unit digit is 5 or 0, then it is divisible by 5. If a number is divisible by 2 and 3, it is divisible by 6. Yes, divisibility property of 6. So 28 last 2 digits together divisible by 4. 4 7 are 28. So whole number is also divisible by 4. So these are the properties of divisibility properties of 2, 3, 4, 5 and 6 like that. Then 7 and 9 and 11 like that we can continue. Okay, simple divisibility property. So now equal, it is divisible by 2, we can understand that 2 1s are 2, 2 6s are 2 3s are 2 8s are. Yes. Next again 2. 2 8s are 2 1s are 2 9s are. So 2 it is not divisible by 2. Next 3. If it is not 5, otherwise 7, 11, 13, 17. Yes. 9 plus 1 10 plus 10 plus 8 18. Divisible by 3. Again divisible by 3. Okay. 91. 91 is not. Which is not divisible by 3, 2, 3, 5, 6. It is divisible by 7. It is divisible by 36. It means therefore 3, 2, 7, 6 equal to 2 into 2 into 3 into 3 into 7 into 13. It is said to be prime factorization. Prime factorization. So, where it is possible to write the given number in the prime factorization. It means every composite number can be expressed as its products of primes. It means you can write 2 to the power 2, 3 to the power 2 into 7 into 13 also. Yes, this can help you to the time of writing the essay. See? So, this is said to be prime factorization. So 6 equal to 2 into 3. This is said to be prime factorization. As simple example, 20 is equal to 2 into 5 means 2 to the power 2 into 5. Yes, this is said to be prime factorization. So now how to find the HCF? HCF, first work is to see the common factor. Yes, 2 is the common factor. Yes, here 2 is having power 1, here power 2. Among them which is HCF. So very careful by the lower class definition and so many examples. To find the HCF, first condition is common. If that is common with the lowest power, very important that is. Common with the lowest power is HCF. Is it? Okay, now 2 to the power 1 which is your HCF. HCF is generally we are mistaken that is highest power. No. First condition is common. If that is common with lower power. Yes. And LCM equal to may be common, may not be common, product of all the terms if the common at that time highest power. That means that 2 to the power 2 into 3 into 5. They are not common. But 2 to the power 2 is common with the highest power, which is equal to 4 is a 4 into 3 into 5 equal to 60 is LCM. 60 is LCM. Understand? So very careful about 2 is HCF, 60 is LCM. Shall we verify that? Is it H into L equal to A into B? Yes. See now, H means 2, L means 60 equal to 120, A into B that is 6 into 20 equal to 1. So the relation between the terms and the HCF and LCM. The product of the two terms is always equal to the product of the HCF and LCM. Or the product of the HCF and LCM of two terms is always product of the term themselves. That is the relation. Then we can help of this. We can, if H is not given, we can find L is not given, we can find A is not given, B is not given, we can find the relation. That is, you can understand that H equal to A into B divided by L. L equal to A into B divided by H. Yes, similarly, A equal to H into L divided by B. B equal to H into L divided by A. These are the relations. Find the HCF and LCM of 4, 45, 75 and 120. Find the HCF and LCM of 45, 75 and 125. S first one 45 equal to S 3 15 the 3 5 the 5 1 the therefore 45 equal to 3 3 into 5 means 3 square into 5 and 75 equal to S not divisible by 2. 3 the 3 25 the 5 5 the 5 1 the so 75 into 3 into 5 into 5 equal to 3 into 5 square 125 equal to 5 3 no that is not possible 5 5 25 5 5 5 that is 125 equal to 5 into 5 into 5 equal to 5 cube. This is said to be prime factorization. So 45, 75, 125 are composite numbers. So fundamental theorem of arithmetic defines. Theorem is every composite number can be expressed as the product of its primes and they are always unique and order is not equal. Okay, that is fundamental theorem of arithmetic. So let's see. Yes, once again, statement means first condition is common, second condition is lowest power. Yes, 3 is not common. So 3 square 3 and 1 it means 1. So 1 is accepted. So 5 is common with lowest power. The accept is 5. What it means? Among these all 45, 75, 125 there are some factors. Among that highest common factor is 5. By 2 it cannot divisible, cannot divisible. By 3 all are divisible. This is not divisible. So from 5 it is divisible. 5 9 5 25 5 25. Understanding? So among that 5 is only dividing the given number, so it is equal to LCM. So LCM. LCM means first common with highest power. 3 is common, so highest power. 5 is common with highest power. Equal to 9 into 125 equal to this is 1125 is LCM. Yes. So to find the LCM and LCM this fundamental theorem helps to write the given composite number, product of the prime numbers. By the help of the prime factorization, you can find easily the HCF and LCM. Okay. Given that HCF of 306 and 657 is 9, find the LCM of 406 and 657. Yes. Here A is 306, B B is 657. HCF is given. To find the LCM. Yes, we know that. LCM means L equal to product of the two terms or LCF. Yes. So we know that H into L is equal to A into B. Therefore, L equal to A into B divided by H equal to A is 306, B is 657 divided by H is 9. This is the answer. Simple relation between. So now 9 ones are simplification is yours. It means that 306 into 73 gives your answer. Yes, multiplication. Here is the answer, which is LCM. Yes, here given that LCM, find the LCM. Here also what are the A and B? A is 150, B is 100. Simple example. Yes, H into L is equal to A into B. Therefore, H equal to A into B divided by L equal to 150 into 100 divided by L is 300. Yes, 300. 3 1 the 3, 2 3 the 3 is HCF. So once again that is, you can also verify that, and 50 is HCF means 50 can divide these two numbers completely. LCM means 300 is divisible by these two numbers. That's a very important meaning. Okay, so some examples for more. And 237. 1, 5, 2, and 1, 2, 1, 5, 6, and 35, then 8. This is fundamental theorem. It can be used to find the HCF and LCF. This is another topic, another part, next class.